Welcome to our presentation. Pseudocode is a high-level, language-agnostic description of an algorithm or piece of software. Pseudocode is different from normal code in that it more closely mimics the natural language that we speak every day. Pseudocode is generally a design technique that is used to communicate an idea without worrying about implementation. Oftentimes, as programmers, we try to describe algorithms in an actual programming language first. But we must realize that natural language has an inherent ability to describe algorithms and software that we want to use on occasion. The process of writing pseudocode helps us brainstorm about our software. In this particular example, the function signature looks a lot different from what you typically see in code. We don't have syntax that's specific to any language. It's a pretty versatile description that can work anywhere. However, we do have words like while and return that are somewhat ubiquitous across different programming languages. As mentioned earlier, pseudocode more closely mimics natural language as opposed to actual programming language. We see phrases like delete the minimum weight tree or create a new tree T with TL and TR as its left and right subtrees. As you may notice, these sound more like English sentences than actual code, or somewhat of a hybrid. In this particular example, we use an arrow to denote an assignment to a variable. The arrow pointing to the variable that's receiving a new value. The idea is that this description is general enough that you can apply it to any programming language you can think of, provided you already know how to program in that programming language.
The trick to pseudocode is to write it out as easy to read as possible so that anybody can read it and write it in whatever programming language they desire. Here, we are going to show an example of pseudocode in our SDD for the home teaching app. To begin, you want to make sure that the reader understands what pseudocode you are writing, so we label it user class right at the top so that the reader can know that the pseudocode below belongs to the user class. Now we can see that there are two Boolean functions that the programmer will need to implement in the user class. The first function is necessary to authenticate the user when they are signing in. We start with our inputs. This is what the function is going to need in order to execute properly. So this function is going to need the user's username and password. Next, we state the outputs. This is what the function is going to return when it is finished executing. In this example, the function will return a true or false. Now we state the purpose of the function. In this function, the purpose is to verify that the username and password that are given to us by the user match one of the entries in our database. If the inputs match an entry in the database, the function will return true and allow the user to log in. If the inputs do not match an entry in the database, the function will return false and deny the user access. The next function is going to check the user's permissions. There are two inputs. The first will be the user's role, whether this be a home or a visiting teacher, an Elders Quorum president, Relief Society president, or whatever role they may have in home teaching. The other input necessary for the function is to execute a permission. This is going to be like permissions to make a home teaching assignment or permission to create a companionship, etc. Once again, this function is a Boolean function, so it will return a true or false. The purpose of this function is to check if the given role of the user has the permission that is given. So if the role was a home teacher and the permission was to delete a companionship, the function would return false because home teachers can't delete companionships. If the function received Elders Quorum president with the same permission, however, the function would return true because an Elders Quorum president does have permission to delete a companionship when necessary.
I'm going to introduce the advantages and disadvantages of pseudocode. Pseudocode can be done easily on a word processor. It's easily modified. It clarifies algorithms in many cases. Pseudocode helps to trap defects before they become code. Converting a pseudocode to a programming language is very easy, as well as pseudocode makes reviews easier. Programming languages are difficult to read for most people, but pseudocode allows non-programmers, for example, business analysis, to review the steps to confirm the proposed code matches the coding specification. By writing the code in human language first, the programmer safeguards against leaving out an important step. Some programmers write pseudocode in a separate document, while others write directly in a programming language, using comments before the actual code. This provides a handy reference during coding. Let's talk about disadvantages. While pseudocode is easy to read, it does not provide us a good map for the programmer. It does not include the full logic of the proposed code. Since it's a basic by nature, pseudocode sometimes causes non-programmers to misunderstand the complexity of a coding project. The lack of standards is probably the main disadvantage of pseudocode. Pseudocode by nature unstructured, so the reader may not be able to see the logic in a step. As you write pseudocode, be aware of these disadvantages.
One of the best times to use pseudocode is when you're writing algorithms. Algorithms can be very complex sometimes and have a lot of parts and processes to it. By writing pseudocode, it allows you to start writing out code to a point where it's easy to transition into code, but allows you to not focus on the syntax as much and just focus on the thought process, the logic, and the ideas and concepts behind the specific algorithm. Pseudocode is also very good to take a step back and review problems with. Since pseudocode, first off, by writing pseudocode first, it allows you to avoid problems that you would usually make when just straight out going to coding instead of planning more first. And also, sometimes if you're having problems, it's good to take a pause from actually writing code and reviewing it, and maybe just writing the pseudocode out on paper, allowing you to reevaluate your algorithm from the very start to the very end, evaluating all your thought processes along the way. This moves into the fact that pseudocode is not language specific. This becomes very vital in teaching and for planning. The reason for this is because first, most of the time the projects sometimes won't have a very language specific yet, or they may be used in multiple languages, and sometimes you need to write the pseudocode for that. In these cases, pseudocode is really good for creating an algorithm that multiple people can copy and rewrite in a different language. Pseudocode also does a great job of pairing with flowcharts. Flowcharts provide a big picture and show how data flows, while pseudocode pairs well with it and goes down another level and describes certain parts of the full program in greater detail.